This is trig day 2. We're going to get into the complete unit circle and talk about all the degrees and radians and the values at those respective angles. So standard position, an angle is in standard position if its vertex is located at the origin. So there's the vertex of that angle is located at the origin. It says, and one ray is on the positive x-axis. So this is the ray that's on the positive x-axis. So this is the initial side. So the initial side is always starting on the positive x-axis. Now rotation going this way is counterclockwise, and that's positive. Rotation going this way is clockwise, and that's negative. So just keep that in mind. Now the terminal side is where the angle stops. And so we know that this is quadrant 1, this is quadrant 2, this is quadrant 3, this is quadrant 4. So that's going to matter because when we do these angle values, they're going to be positive in the first quadrant. X will be negative in the second quadrant, but Y will be positive. In the third quadrant, they will both be negative. And in the fourth quadrant, the X will be positive, but the Y will be negative. So this changes the value of the angle or its location. So if the terminal side lands on an axis, then we call that a quadrantal angle. So that angle it could land on could be 90, it could be 180, it could be 270, okay, 360, or 0. Okay, so those are the quadrantal angles. So those are the special ones. And oftentimes the ordered pairs that are associated with those are really easy. Like the ordered pair here is 1, 0. The ordered pair here is 0, 1. The ordered pair over here is negative 1, 0. And I mean by that right here. And then over here is going to be 0, negative 1. So X and Y are pretty easily determined and pretty simple solutions. Now angles that are coterminal, their terminal side stops in the same place. So notice that when we look at this angle here, that its initial side is on the positive x-axis and its terminal side is in the second quadrant. Now, whether we go around negative 240 degrees or whether we go around a positive 120 degrees, we still end up in the same spot. So now if we look at the difference between these, we could say 120 minus negative 240, and we find out that they're exactly 360 degrees apart. So coterminal angles have to be 360 degrees apart, and there's an infinite amount of coterminal angles to each respective angle. As long as you are 360 degrees apart, you are good to go. Okay, so this is mostly just definitions on this page, so pause if you need to write down what additional information I did, and then we'll move on to the next screen. Now, oftentimes the values with trig functions repeat themselves, so reference angles are very important to us. Okay, so reference angles are associated with every angle drawn in standard position, except for quadrantal angles. Okay, there is another angle called the reference angle. The reference angle is the acute angle, the smallest angle formed by the terminal side of the given angle and the x-axis. Let's say that again. The reference angle is the acute angle, which is the smallest angle, formed by the terminal side of the given angle and the x-axis. So very important we understand that. So this x-axis here is what we're always referring to. Okay, so keep that in mind. Now, in the first quadrant, the formula to find the reference angle is, and I'll just use R for reference angle. So the reference angle is equal to the angle which we will just call theta. And if I haven't said so before, theta is just a Greek letter used to represent angles. So theta alpha, beta. These are all Greek letters that are used to represent angles. So like I can say sine theta, I could say cosine beta, I could say, that was a very good beta, I could say tangent alpha, and it's just, they just represent the angle, so don't worry about that. So for Q1, the formula to find the reference angle is the angle given is the reference angle. Okay. In Q2, we have to say, well, the angle here is 120 degrees, right? So, but the reference angle is 60, so how do we get that? Well, 180 shows up. So the reference angle is equal to 180 minus the given angle. So 180 minus 120 gave us 60, which was the reference angle. Now, not to confuse you too much, but if it was in radians, and this would be pi minus theta. Okay, just keep that. Okay, so for Q3, so Q3 angles, notice this is 240 degrees, so that's a quadrant 3 angle. Okay, so reference angles have to be positive. So we're going to take the angle and subtract 180 from it. So I mean, like, okay, 240 minus 180, and lo and behold, my reference angle was what? 60 degrees, wasn't it? Okay. And then for Q4, my reference angle is going to be 360 minus the given angle. So in this problem, it was 315. So 360 minus 315 gives me 45, and 45 is my reference angle. Now, just a disclaimer here, this would be theta minus pi if you were in radians, and this would be 2 pi minus theta if you were in radians. So it's good to know for each quadrant how to find the reference angle, and those are the formulas of both degrees and radians. There's also a little link here to give you some reference angles to help you find reference angles of positive and negative angles, so you can check out that link. If you do that. So pause if you need to. I'm going to the next screen. So now our focus is going to be building all the ordered pairs for the unit circle for the special angles that normally have a reference angle of 30 degrees, 45 degrees, or 60 degrees. So now from yesterday's notes, we know that 30 degrees had an ordered pair of root 3 over 2 and 1/2. And we know that this was the cosine value of 30 degrees. We know this is the sine value of 30 degrees. Okay, so we want to use our reference angle to be 30 degrees. So that means over here in Q2, it would be R is equal to 180 minus, sorry, let me do that again. Your reference angle would be 30. Here your reference angle would be 30. And here your reference angle would be 30. So now how do we do that? What type of angle would give us a reference angle of 30 degrees? Okay, so this is 180. If I wanted this to be 30, then this would have to be 150, right? If I wanted this to be, oops. If I wanted this to be 30 as well over here, let me move this a little bit, it's a little messy here. So this is 30 in here, this is 30 in here, this is 30 in here. What angles would be at these positions? Well, this would have to be what? 180 minus the 30 would give us 150 out here. Okay, 180 plus 30 here would give us the 210. And then here it would be 360 minus 30 would give us a 330 here. So we notice that 30 degrees, 150 degrees, 210, 330, all of these have a reference angle of 30 degrees. Okay, so now when we build our ordered pairs for them, they should have really the same value of an ordered pair, because the initial angle that we're looking at is 30 degrees for all of them. So what we notice is that 150, it is a negative root 3 over 2 comma 1/2, because this would be negative x, y, because you're in Q2, right? Now over here, it's going to be a negative root 3 over 2 comma negative 1/2, because you're in Q3. In Q3, it's negative x, negative y, okay? And then in Q4, it's going to be root 3 over 2 comma negative 1/2, because the ordered pair is going to be x comma negative y in Q4. Okay, so that's the big idea here. Okay, that is the big idea here. Now we want to do the same thing for the 45 degrees, and we want to do it for the 60 degrees as well. So we want to think about that and what angles are going to come up and what we will see. So pause if you need to. I'm going to the next screen. So when I look at this first one here, I'm going to do 45 degrees on it. So we do 45, and from yesterday, that ordered pair was root 2 over 2, root 2 over 2. And so let's say we do 45s, and I'm drawing this by hand, so I'm just a little bit of guess here. So this is 45. Well, this is 45. That means this is 45. That means this is 45. That means this is 45. Okay, so when we think about that, what does that mean to us? Well, 180 minus 45 gives us 135. So that must be the angle here at this location. And the ordered pair should be negative root 2 over 2 comma root 2 over 2. And then 180 plus 45 would give us 225. So that would be the angle. And then the ordered pair would be negative root 2 over 2 comma negative root 2, because this is negative x, negative y, because it's Q3. And then last but not least, this would be 360 minus 45. That would give us 330, or 315, I'm sorry. 315 here. And remember that this would be root 2 over 2, and then negative root 2 over 2, because this is Q4, and Q4 is x, negative y. So all the ordered pairs match except for the sign. And the sign is different because you're in a different location, but your reference angle is the same, because we realize, you know, as we draw these, you know, triangles in here, it sort of makes a bow tie, if you will, and that gives us these angles, and gives us the trig functions of those angles. So it's a very, very handy device to use. Now, for 6, again, pause if you need to. I'm going to the next screen. And I'm sorry, I can put 45 up there. Well, I'm scrolling a little bit. Now we're going to do 60. So for 60 degrees, that means, you know, 60 degrees, 60 degrees. So if this is 60, that means this is 60. If this is 60, that means this is 180 minus 60. This would be 120. This is Q2. So that's, sorry, that's negative XY. Also, the ordered pair from yesterday here was 1/2, comma, root 3 over 2. And don't forget, the first one's the value of cosine, the second one's the value of sine. Very important, we know that. So over here would be the ordered pair. What's ahead here? Negative 1/2 root 3 over 2. So we would do 180 plus 60. That would give me 240. So this is going to be negative x, negative y, because it's Q3 down here. And that order pair would be a negative 1/2, be a negative 3 over 2. And then this would be 360 minus the reference angle 60 would give the angle 300. So I get 300 over here. So this is 60 here. And remember, everything references the x-axis. Very important to understand that. So the order pair here would be 1/2 negative root 3 over 2. Because this is Q4. Q4 is x negative 1. So as long as you pay attention to your signs, you should not have any difficulty. So with that said, you want to sort of put this together and pause if you need to, but I'm going to the next screen. So from yesterday, the first quadrant should have been 1, 0. This was 0 radians, 0 degrees. This was 30 degrees. This was pi over 6 radians. This was root 3 over 2. This was 1/2. This was 45 degrees. This was pi over 4. This would have been root 2 over 2 and root 2 over 2. This would have been 60 degrees. Pi over 3. And this would have been 1/2 and root 3 over 2. And this would have been 0, 1. And this would have been, I guess we can say this was 90 degrees. And you'll say that it was pi over 2. Your paper will be a little different because I clipped this from the thing and made it large. So put yours in the right spots. That's all I got to tell you. I'm sure the degrees on the left and the pi's on the right. So pause if you need to. I'm going to the next screen. Okay, you should be able to fill out this information now. Yeah, see, I can see it was 9 degrees. Okay, so this would be the 120. This would be the 135. This would be the 150. And this would be the 180. So this would be the pi. This would be the 5 pi over 6. This would be the 3 pi over 4. This would be the 2 pi over 3. And the ordered pairs of transfer. And this would be a negative 1/2. This would be root 3 over 2. This would be negative root 2 over 2. This would be root 2 over 2. This would be negative root 3 over 2. This would be 1/2. And this would be negative 1, and this would be 0. And that is your quadrant 2, right? So this is your Q2 stuff. Now, we go back, this would have been your Q1 stuff. Okay, pause if you need to. I'll go to the next screen. I don't think I did a good job of capturing the little sections here, but this would be 210. This would be 225. This would be 240. Over here would be 270. And I'll put a couple of dashes here for the quadrant point down there. And so this would also be 3 pi over 2. This would be 4 pi over 3. So 5 pi over 4, and this would be 7 pi over 6. And again, this would be negative root 3 over 2. I can use those other parts as my fraction. Negative root 3 over 2, negative 1 half, negative root 2 over 2, negative 2 over 2. This would be negative 1 half. This would be negative root 3 over 2. This would be 0 and negative 1. So keep in mind your x's are cosines, your y's are sine. Pause if you need to, I'll go to the next screen. Okay, so that means that we have to finish this out. So we already did the bottom, so I'm not going to do the bottom again. This is just going to be 300, 315, 330, which makes this 11 pi over 6. This makes this 7 pi over 4. This makes this 5 pi over 3. So this makes this 1 half, negative root 3 over 2. This makes this root 2 over 2, negative root 2 over 2, 315. And this makes this root 3 over 2, negative 1 half. So basically that takes us around, and again, you would end up here, this would be 1, 0. Okay, so you could say that this was 360, you could say this was 2 pi. Okay, it's always good to have that on there too. Okay, and that should finish out your unit circle. And so basically you're going to use that to answer questions. Pause if you need to on both next week. So basically this is like a treasure hunt. You look for these values when they occur. So you're going to find out this occurs more than once. So go ahead and try to fill out this little sheet of paper and then come back in and check your answer with me once you have it filled out. We'll see if you're right. Okay. Okay, so let's see how you did on the first few. So if the x-coordinate is root 2 over 2, that means when is cosine. Okay, when is cosine theta root 2 over 2. Okay, and that happens at 45 degrees, which is pi over 4, or 350 degrees, or 7 pi over 3. Okay, so when is the y-coordinate root 3 over 2? So that means we're talking about sine theta. When is sine theta equal to root 3 over 2? Well, that's 60 degrees, which is pi over 3. Or 120 degrees, which is 2 pi over 3. Remember, the y-coordinates above the x-axis are positive. Okay, just keep that in mind. Handy piece of information. Now, if the x-coordinate is negative root 2 over 2, then that means cosine is negative. When is cosine negative? Well, cosine's negative whenever x is negative. That means it's to the left of the y-axis, so that means it will be the second or the third quadrant. So 135, 3 pi over 4, or 225, 5 pi over 4. And then it asks you when the y-coordinate is a negative 1, so that's quadrantal, so that happens at the bottom, so that bottom is 270, or 3 pi over 4. Okay, so pause if you need to. I'll go to the second half of this. Okay, so this is like the second half of that little portion, so go ahead and finish this out if you haven't already. Pause your screen, work these problems out, and unpause it to check your answers. Okay, let's check your answers. So when's the x-coordinate of negative 1/2? So cosine theta is negative in Q2 and Q3. So 120 degrees, 2 pi over 3, or 240 degrees. If the y-coordinate is negative, so that's sine theta. Sorry, minor interruption there. Sine theta was equal to a negative root 3 over 2, so theta is equal to 240 pi over 3, or 300 degrees, 5 pi over 3 sine is negative in quadrant 3 and quadrant 4. Y is negative below the x-axis, so that's quadrant 3 and quadrant 4. If the x-coordinate is 0, that means you're on the y-axis, so that would be 90 degrees, which is pi over 2, or 270 degrees, which is 3 pi over 2. And then they said find cosine of 135. So you look at your unit circle, pick the x value. Cosine is the x value. Find 10 to the 300. I'll go through that in a minute. Find sine of 2 pi over 3. That's going to be the y value of 2 pi over 3. So that's root 3 over 2. Again, it's in the second quadrant, so sine is positive. Find cosine of 7 pi over 6. That's going to be x value in the third quadrant at 210. So it's going to be a negative root 3 over 2. Now, tangent of 300 degrees means I need this ordered pair right here. So that's the ordered pair at 300, and that's x comma y. So remember, tangent of 300 degrees is going to be y over x. So the y coordinate over the x, the y value over the x value, and then I need to simplify it. So finally simplifies out to be a negative root 3. Okay, and that's in the notes. And, I'll go ahead